Good morning, I am Nikita BS. Introduction to First Come First Serve Scheduling. First come first serve scheduling is the oldest and simplest CPU scheduling algorithm used in operating systems to decide the order in which process should be executed. It works on the basic principle that process the which arrives first gets the CPU first, similar to a queue at a ticket counter. In first come first serve processes are placed in a ready queue based on their arrival time. The CPU handles them in exact order they enter the queue. Since first come first serve is an non-preemptive, once a process starts execution, it continues until it finishes. Even if another process with a shorter execution time arrives, this scheduling method is easy to implement using a first in first out queue and ensures fairness with respect to arrival time. However, it can lead to poor overall system performance because longer processes may delay shorter ones, creating the well known conveyor effect. Experimental setup of first come first serve. To study a first come first serve scheduling algorithm, the experiment is set up by first preparing a set of processes, each defined with an arrival time and a burst time. These processes are fed into a ready queue implemented using first in first out structure. The system environment may include any computer with a basic programming tool such as Python, C, or Java to stimulate the algorithm. The experiment begins by sorting the process based on their arrival times, after which the CPU starts executing them in the exact order. They enter the queue which process is allowed to run to completion since first come first served is non preemptive. During execution, important performance meters such as start time, completion time, waiting time, and turnaround time, CPU utilization, and throughput are calculated. By analyzing these values, the behavior of first come first serve, such as long waiting times when a large job arrives first, can be observed. The experimental setup may also involve testing different sets of processes which varying arrival and burst times to study the concave effect and compare first come first serve performance under various workloads. Implementation steps of first come first serve scheduling algorithm begins by taking input for a set of process including their process IDs, arrival times, and burst times. These processes are then arranged in ascending order of arrival time, ensuring that the process that comes first is executed first. After sorting, the CPU starts scheduling the by checking each process in order. If the CPU is idle before a process arrives, the current time is moved forward to a arrival time of that process. For each process, the starting time, completion time, waiting time, and turnaround time are calculated. The process begins execution when the CPU time is available and continues until its burst time finishes because first come first time is an non-preemptive. Once a process completes, the CPU moves to next process in a queue. After all processes have been executed, the program completes overall performance meters such as average time, waiting time, and average turnaround time. These steps complete the first come first serve implementation and allow analysis of its behavior. Working of first come first serve scheduling. Process arrives in the ready queue. Each process enters the queue in the order it arrives. CPU selects the first process in the queue. First come first serve uses FIFO, first in first out structure. The settled process runs until completion. First come first serve is a non-preemptive, meaning once a process starts running, it cannot be interrupted until it finishes. After completion, the CPU picks the next process from the front of the queue and repeats the cycle. Example, suppose the process arrive in order. Process 1, the burst time is 5, and process 2 burst time is 3, and process 3 burst time is 2. Execution order is P1 to P3, P3 to P4. Each process waits until all process before it have completed. The key points of first come first serve is simple and easy to implement, non-preemptive, order based only on arrival time, can cause long waiting times. Observation of first come first serve. Observation for implementing and analyzing the first come first serve scheduling algorithm show that processes are executed strictly in the order of their arrival. Observation. The observation for implementing and analyzing the first come first serve scheduling algorithms show that processes are executed strictly in a order of their arrival, which makes the technique simple and fair in terms of arrival time but often inefficient in performance. Shorter process may experience long waiting times if all process arrives before them, leading to a concave effect where all other processes are forced to wait behind a large job. These results in increased average timing, waiting time and turnaround time, especially in workloads with mixed short and long processes. First come first serve is non-preemptive, so once a process starts, it runs until completion, which simplifies CPU management but reduces responsiveness for interactive or time critical tasks. The algorithm performs well when all processor has similar burst times on arrival times and at regular intervals, but efficiency decreases when arrival times vary greatly. Overall, the observation highlights that first come first serve is easy to implement but not optimal for environments requiring high responsiveness or minimum waiting time. Next is the code. Um, this is the code. After running the code, output is the output comes like this. Enter the number of process. Enter the number of processes. The number of processes is 3. Number of processes is 3, and then enter the arrival time of P1. The arrival time of P1 is 0, and next enter the burst time of P1 is 5, and next arrival time of P2 is 1, and next burst time of P2 is 1 3. Enter arrival time of P3 is 2, and burst time of P3 is 8. Here the scheduling result, 1 2 3 is the number of processes, and 0 1 2 is arrival time of P1 P2 P3, and burst time of P5 3 8 is burst time of process 1 2 3. Here the complete time and total around time and waiting time is calculated. The Gantt chart is shown in this output. The Gantt chart is the first process is started at 0 arrival time and complete at P1 is complete at 5, and P2 is started at 5 and ended at 8, and P3 is started at 8 and ended at 16. Thank you.